Hi everyone, I'm from Group B2 and today I'm going to discuss and explain about our assignment according to the Node-RED. So in the Node-RED page, here we're containing three flows. So firstly, which is the uploading the sensor data and save the sensor data into the collection, which is the sensor data. Secondly, the flow shows that this is a configuration for the ESP32 sensor. With the controlling in the smoke threshold and the detect interval. The function of the smoke threshold in our ESP32 is to activate the alarm system, and the detect interval is our time looping for the sensor data upload to the MQTT and save into the database. Thirdly is the flow that we can register the new device for our ESP32. As example, I want to register a new device which is named ESP3202. So I can choose this HTTP post request and use the operation insert1 into the device metadata. So after we done the registration, so we can do the verification identity. So we can find in the collection device metadata to prove that our device is already do the registration. So there is some important part in our Node-RED flows. Firstly is our function 1. Function 1 is function to our maintain our sensor data. Just want to do the verification of our key, which is the device ID in our device metadata. After it successfully do the verification, it will go to another function, which is another node, and here contain to adding the timestamp and the local time to our sensor data. After that, we can do the operation insert1 to insert our sensor data into the time series collection, which is the sensor data. Another important part is our MQTT out, which is have a topic IoT /sensor /config. For this MQTT out, we set the return to the true because in the real world case, it may have some condition that ESP32 sensor is not active, but the user still want to configure the smoke threshold and the time interval, the detect interval, so it can just configure it anytime. After the ESP32 active or on, it will immediately receive the configuration message and configure the smoke threshold and the detect interval. After the Node-RED part, we're looking for the MongoDB part. So in our database named UTM IoT assignment, we have two collections. Firstly, which is the device metadata, and secondly, which is the sensor data with the time series collection. When we're looking at the device metadata, it is functionally for the verification of our device ID. So after the successful verification, we continue with the adding timestamp and the local time. So after that, we will save and use the operation which is insert1, insert our sensor data into the time series collection sensor data. So look at here, we can see that we got a timestamp and with the local time and the sensor data in our database. So after we already discussed about the Node-RED flow and the MongoDB database with the collection, we also do the security that related with the MQTT EMQX Cloud Console authentication and authorization and the specific privilege in MongoDB. So firstly, we do the two topic. We create two topic, which is the IoT sensor config and IoT sensor data for the username that which is Node-RED and the ESP32. For the specific role for the ESP32, the sensor data is just for the publish to the MQTT and the subscribe to the configuration topic. So same as for the Node-RED. Node-RED is subscribed to the sensor data which published from the ESP32, and Node-RED will publish the configuration message to the MQTT, and the ESP32 will receive it. So other than that, we also do the same thing in the MongoDB specific privilege for the two collection, which is the sensor data and device metadata. So we have give these two collection with the same operation, which is the read write. So look in the Node-RED flow, we can see that MongoDB have a URL that have a security, which is I already hidden the username and the password. So I click to cancel. So make sure that I can return back to my original username and password. Other than that, I also do the EMQX security, so which is the Node-RED. Now, I'm gonna to demonstrate our fire monitor system, which is function or not. So for this system to function, the temperature need to reach above or equal with 45 degrees Celsius, and the smoke roll need to detect
to the 1000. So I prepare with the fire protector and the smoke protector. So firstly, I gonna use the lighter to rise up the temperature for the DHT22 until reach to the 45 degrees Celsius. So I have a PC which is have a debug to let me demo and see whether the temperature is reached or not. So after that, I'm gonna put this building below the DHT below the MQ2. So at that, I can burn out this smoke detector and use this building to concentrate my smoke below the MQ2. So until the temperature and the smoke reach and above to the 45 degrees Celsius and the smoke threshold which is 1000, it will output the buzzer and the LED will light up until the next looping reach the temperature and the smoke sensor below the temperature and smoke threshold.
So just now is our hardware system demonstration part. So now we're looking for the node red flow and the MongoDB. I extraordinarily put a debug node to make us demonstration video easier to observe our sensor data. So firstly, when we look at the MSG payload, which is a debug, so we can observe that we have a device ID. The early we already setting, which is ESP3201. So for the device ID, we can do the verification. So firstly, we will find in the device metadata collection. So after that, when it is successfully verified, it will go to the next function, which is to adding a timestamp and the local time. After that, it will insert with the operation insert one and insert the sensor data into the collection, which is the sensor data. So the debug node show that when the temperature already reached above to the threshold temperature, which is 45 degrees Celsius, but the smoke row is still below the smoke threshold, which is 1000. So the smoke is output of false, and the LED and the buzzer is not function. After the time interval, which is 10 seconds, the temperature is still remain above the threshold temperature, but the smoke row also reached and above to the smoke threshold, which is 1295. So the buzzer and the LED is start to output until the next time interval, which is another 10 seconds. The next 10 seconds, the each one temperature or smoke row is below the threshold. So we look into the MongoDB. So here containing our sensor data is saved into our time series collection, which is the sensor data, and we look at the device metadata. We have two devices, but just now our sensor device is ESP3201. So it will successfully find in this collection and go to the next function, which is the insert one, and insert our sensor data into the collection sensor data. After we do the all hardware and the software connection, we also prepare our dashboard to make us see and observe from the time series collection, which is the sensor data. So we prepare a Gauss graph and the table and the combo graph, which is the line and the histogram for the topic, which is temperature and humidity trends, and with the smoke sensor with the group column. And we can see that some output at here with the identify color at here. So that's all from us, Group V2. Thank you.